Okay, so now we will study the combination of resistors. So resistors, we can combine the resistors in two ways. One is in series and another one in parallel. So we will study how to connect the resistors in series. Okay, suppose if I take three resistors. So this is my one resistor, second and third resistors. I will name it as R1, R2 and R3. Three different resistors. So they are connected in series. Okay. So see, this one end is connected to another end of different resistor. This end is connected to another end of different resistor. So we can say that it is connected in series. Okay. So we have to find the equivalent resistance. So now what is equivalent resistance? Instead of I want to make use of only one resistor instead of these three resistors. I don't want to use three different resistors. I want only one resistor to use which has the value of all these three. Okay, equivalent to these three resistors. All the three in the sense equal to the three resistors. So that is we call it as RS, which is called as equivalent resistors. So resistors in series. Okay, so RS. So instead of three resistors, I want to make sure that I want to make use of only one resistor. So now see, I'll connect this to a battery. Okay, this is my key, and across this point, so this point and this point, we have to connect a voltmeter. And if you want, you can connect an ammeter. So this is my ammeter. Now we have to find the equivalent resistance. So see, this is my plus sign and this is minus sign. Okay, so one thing you have to remember that voltmeter and ammeter. Now if I take this three bulb, this is my one bulb, second bulb and third bulb. So when we connect three bulbs in a series, the current flowing through it is same. So the same current will flow. If I am supplying 5 ampere, 5 ampere will be pass to same thing. Means 5 ampere, 5 ampere, 5 ampere, 5 ampere. The current flowing through the circuit will remain same. Okay. Similarly in this, the current will be same. So what will change if I will connect this to a voltmeter? Okay, so if I connect this to a potential difference, each one will have different potential difference. Okay, so you have to, in series, you have to remember that the current flowing through the circuit, okay, current is same throughout the circuit, whether it is from resistor 1, 2, 3, the current will same throughout the circuit, but the potential difference is different for each resistor. Okay, so it is different for each resistor. So you have to remember these 2 points. It is very important while solving the problems. So what I'll do now, see the potential difference, I'll give individual potential difference to each resistor. So this is my R1, this is my R2 and this is my R3. Okay, so the ammeter, now I'll give this as V1. Here it will become V2 and here it will become V3, and this is my cell. Sorry. Okay, so now what I said, the current, now the current is same I, the current is same I throughout the circuit. Throughout the circuit the current will be same, the potential difference will be different. Okay, so the total difference, the total potential difference will be given to each part. Okay, so I can write this as total potential difference is sum of individual potential difference. So if I'll add V1, V2, V3, I'll get V, total potential difference. So if I'll give you, for example, 20 volts, 20 volts will be divided to each resistor. Okay, it might be same, it may not be same depending upon the resistor. So for example, this will be having 10 volts, this will be taking 8 volts, this will be taking 2 volts. So 10 plus 8, 18 plus 2, 20. So my total potential difference V should be the sum of individual potential difference. Whereas the current is same. If current is 5 ampere, the 5 ampere is moving same equal to throughout the circuit. Okay, so throughout the circuit the current will be same. Now what we will do, we will apply Ohm's law to individual resistor. see V, I know the Ohm's law, I is equal to, V is equal to IR. So instead of V, I'll substitute IR. Instead of V1, what I'll write? See, the current is same. So V1 can be written as I into R1. Why I? Because the current is same. So I am not taking I1, I2. Current is same I. So V1 is equal to I into R1. V2 is nothing but I into R2. Why R2? Because V2 is across R2. So here also the current is same only. So instead of V2, I have written I2, IR2. So here V3, so I into R3. So if I'll take common, so I'll take I as common. So inside the bracket, so R1 plus R2 plus R3. So I and I get cancelled. So R is equal to R1 plus R2 plus R3. So this is my equivalent resistance. So this is how we find equivalent resistance of series. So instead of RS, okay, instead of using R1, R2, R3 different resistor, we can make right as RS. So which is sum of all the resistors. So if I'll give you a 3 ohms, 4 ohms, 5 ohms, then we can say that total resistance is equivalent resistance is 3 plus 4 7 plus 5 12. So you can make use of 12 ohm resistors instead of 3 different resistors. So this is how you solve the resistors in series.